Welcome again. Hopefully you've watched the first video on General Solutions Introduction, explaining what it is, so that now we are going to apply the knowledge of general solution to solve equations that have to do with trigonometry. Now, before we go into that, there are some concepts that you are required to know at this level, some of them being the following. You are expected to know that the multiplication of any two numbers or expressions can only give you 0 if one of them is 0. So a times b can only be 0 if a is 0 or b is 0. That one we've had since grade 2, that the only time you get a 0 as an answer from a multiplication is when one of those numbers is exactly 0. So we will carry that forward. This we had from grade 10, the cast method, as well as the reductions from grade 11 for each and every quadrant, as well as knowing where each sine or cosine or tan graph is positive or negative. Then we have some identities that we will go into or need for some exercises. The others we will write as we need them. Then we also have this issue of period that we touched on in the previous video, that sine and cos base period is 360, tan base period is 180, and then we will have other factorization techniques that we need, such as the difference of two squares. But the first one that we are going to do has to do with the factorization by removing common factors. So the idea is that remove a common factor so that you can get to this position here. So let's look at it. So here we have ourselves sine x, 2 sine x, cos x, and another negative cos x on the other side. So we want to solve for x. However, we can't just do the shift sine or shift cos because there's the other trigonometric function that's here. Resist the temptation of dividing by cos both sides, please, because it will make you lose half of your answers, therefore half of your marks would be gone. So what do we need to do? We need to take this to the other side, so we have 2 sine x cos x equaling, or this one moving from the other side comes this side, becomes positive cos x, therefore leaving us with a 0. Then from there, we have a cos x here, a cos x there, separated by a plus, therefore we can take out cos x as a common factor. Then that leaves us with 2 sine x from this side, and then from this side, please, you've taken out everything, so 1 gets left behind. Why? Because when you multiply in this cos, you should be able to get back what you had before, so you shouldn't change the expression. We are just removing a common factor. Therefore, we have then equal to 0. So here, just take note that this is multiplication. Therefore, we are currently at this situation. We have an expression, cos x, times another expression, 2 sine x plus 1 equaling 0. So what does that mean? That means that cos x must be 0, or 2 sine x plus 1 must be 0, as per the fact we had. Now, this leads us to solving two different equations. So one of those equations will be done for this side, the other one for this side, where we will start. So this is 0, the number. So we need to get the reference angle now. So the reference angle would be x is equals to cos inverse or shift cos 0. That gives us 0, the angle, so 0 degrees. So this is our reference angle. Now, 0 degrees. So 0 degrees is the reference angle. That's considered to be positive in the cases of the trigonometric functions. Therefore, we are going to do the first quadrant for cos, which is x is equals to 0 degrees plus k times 360, where k is an element of integers. Then we are going to do the fourth quadrant, where cos is also positive as per the cusp. Therefore, we have x is equals to 360 degrees minus the reference angle of 0 degrees plus k times 360, where k is an element of integers. So that tells us that we have 360 degrees plus k times 360, where k is an element of integers. So some may realize we didn't need to write this one because it is already included in the first one. However, I always say that just write them out so that if it's redundant, you don't lose any marks, but if it's required then you would lose marks for not writing it. So get used to writing both quadrants for every trigonometric function. For 10, we will talk about it. It's usually not important because of the period of 10. Now let's look at the other side. For the other side, we have 2 sine x plus 1 equals to 0. That means that we need to solve for x, so everything needs to move out. So here we have 2 sine x. The 1 is positive, going that side becomes negative. Then we are going to divide by 2 both sides, so divide by 2, which cancels out that 2, leaving us with sine x equals to negative half. So now we're in a position to do the reference angle. But I need to highlight the following. The sign that's here is an indication of quadrants. So this means that sine is negative, so that's quadrant 3 and quadrant 4. Which means that when you do the reference angle, because we want to get the acute positive angle, you can ignore the sign and just after that you will then apply that it's in the 3rd quadrant and 4th quadrant. So what do we have? We have x is equals to shift sine of half, which gives us a reference angle of 30 degrees. But we mentioned that it's in the 3rd and 4th quadrant where sine is negative. Therefore, we start with the 3rd quadrant. That means that we have x is equals to 30 degrees plus, this one would be 3rd quadrant, so we need a 180 degrees plus 30. This is the better way of writing it. Then k times 360, where k is an element of integers. That means that our final answer would be x is equals to 210 degrees plus k times 360. Again, k is an element of integers. Don't get tired of writing that because it's very important. Then we are not done. We need to do the 4th quadrant. So for the 4th quadrant, we have the expression is 360 minus the reference angle. So we will have x is equals to 360 degrees minus 30 degrees plus k times 360, where k is an element of integers. So that gives us x is equals to 330 degrees plus k times 360, where k is an element of integers. So that is the final solution. So for these types, we usually have 4 solutions. Sometimes some of the solutions are not applicable or redundant, but in general, we have 4 solutions. Then I have prepared this exercise for you guys so that you can try it out and you can check on your textbooks online, check for similar exercises and just try to do them. Later on, we will do another video that will deal with the trinomial factorization. So we'll have the trinomials as well as the difference of 2 squares factorization. That will help us, as well as the last part that we mentioned also in the other video is the factorization or the solving for x actually, that involves a change in the periods of the graphs. So there'll be a change to these 360s that are done by what changes the period.